guys, welcome back to TechDose, and in this video we will see the kth smallest in lexicographical order problem, which is from lead code number 440. A prerequisite before solving this problem can be lexicographical numbers, which is a easier version of this problem. I have already uploaded a video on this, so please click on the I button or look at the link in the description below. Let's look at the problem statement. In this problem, given two integers n and k, return the kth lexicographically smallest integer in the range of 1 to n. So given n equals to 13 and k equals to 2, I will be enumerating all the sorted order lexicographical numbers. In this case, the one with the second rank, the second position, has to be returned as an answer. So the answer is 10 in this case, right? Now let's look at the possible solution that we had used in lexicographical numbers. In that problem, we had actually enumerated everything using a DFS tree, using a simple recursion, or even you can do it by a for loop or while loop. But in this case, will the same technique work? Now if you look at the constraint, the n is less than equals to 10 to the power of 9. So definitely I want the solution in less than 10 to the power 8 operations to pass it in 1 second. So definitely this is going to give you TLE. This is not going to work. Okay, so you cannot enumerate all the values according to this recursion tree diagram. In order to just recap, the first digit will have options from 1 to 9. But after the first digit, every other digit, which is not the most significant digit, it can have options from 0 to 9, okay, not from 1 to 9. So accordingly, I have made the recursion tree diagram, and if you keep moving to the left, then these will give you the lexicographically increasing ranked numbers. So 1 will come first, then 10, then 100, and 1000 would have come next, but then this is going outside of our n value, which is 536. So the constraint of the question maintains that we should not go beyond n. And therefore after 100, the next number would be 101. Okay, so we have already seen all this in the previous problem. So in this problem, we have to skip some numbers if we have to actually arrive to our kth ranked number, right? Because k can go till n. Now before understanding about the solution, the most important thing to note is all the numbers with the prefix 1, that means all the numbers which starts with 1 will always occur before all the numbers which starts with 2. This is common sense, right? So you see that all the numbers starting with 1 will always have a lower rank than any number which is starting with 2, be it 2 itself, okay? So 1924 will even come before 2, right? Now, if we can count the number of integers which are starting with 1 but less than equals to n without traversing them all, then the time complexity will be optimized, isn't it? So what we need to do is, in this recursion tree, if I tell you that find out how many integers are there between the 1 and 2, that means if I start at 1 and I reach to 2, then how many integers will I be producing? If I can count that without even having to traverse and make the recursion calls, then I will get the optimal result. So this problem is about skipping a large set of numbers and just focusing on how you skip and arrive to the kth smallest lexicographical number. Okay, so in order to understand the solution, we need to see the dry run very carefully. So what I will do is I will be making this recursion tree diagram with Scratch with the logic of skipping. Okay, I would like to announce about our live training programs, data structures and algorithms, which is interview dose, and system design, which is design dose. If you are looking for making a switch from service to product based, or even make a product based to product based top tier switch and aiming for your dream company, this is the best curriculum you can ever join. I'll be your mentor throughout the cohort, and I will help you clear all your doubts in the one-on-one sessions. You can know more about this by querying us on the WhatsApp number, or you can also visit our website techdose.co.in. So let's look at an example. Let's say that n value is equals to 536, right? So let's say that my current value, wherever I will start, I will always start at 1 because this is the lexicographically smallest number. Okay, so I will start at 1, and my current k value will be 236. Because wherever I am present, I will assume that this number is included. So if I start at 1, the 1 will be included. Okay, so if I have already included 1, then the k value is, I need to see 236 more numbers in order to arrive to the kth number, right? So where I will be starting, I will be making the recursion tree diagram here. So I will be starting at the root node, and my current value will be 1. So I'm at the node 1. Now side by side I will try to find out how many integers are there before I arrive to 2. Okay, before I start any number with 2, how many integers are there? So in order to enumerate that, what you need to do is you need to take a prefix 1, which the prefix 1 will tell you all the numbers which starts with 1, and prefix 2 which says all the numbers which starts with 2. Okay, now you find out the difference in between this 1 and 2. The difference value in this case is equals to 1 for now. Okay, and try to go to the next lexicographical number of each of them. So the next lexicographical number for 1 is 10, and for 2 it will be 20. Okay, now find out the difference. It is 10, so add 10 to it, right? Again go to the next lexicographical number, which is 100, and in this case it will be 200. Find out the difference. It is 100. Okay, now go to the next lexicographical number, which is 1000 in this case, and this is 2000. So when you arrive to this number, you know that this is out of bounds of the n value, so you will go back. Okay, this you can easily do with while loop. I will show you in the code how to do that. So how many numbers lie in between 1 and 2 is the gap between 1 and 2, the gap between 10 and 20, and the gap between 100 and 200. Why are we doing all these things separately? Because we are adding the numbers for different digits separately. Like for 1 digit number, anything which starts with 1 and anything which starts with 2, how many elements occur in between? There is only one value, right? So that's why it is 1. Now for anything which is of 2 digit, if something has to start with 1 versus something has to start with 2, what is the difference? Like it will come from 10 to 19, isn't it? So it will be 10 numbers. So that is why I have included 10 here. And for 3 digit, how many numbers come in between when I start a 3 digit number with 1 versus when I start a 3 digit number by 2? So it will be from 100 to 199, which is 100 numbers, right? So the total contribution of 1 as a prefix will be the contribution with 1 digit, the contribution with 2 digit, the contribution with 3 digit. And if this n value was, let's say, 1536, then I would have also counted the contribution with 4 digits, right? But this is not the case in this case, so we were going out of bounds. So the total contribution of the number of items before starting any number starting with 2 will be equals to 111, right? So we know that before even starting any number with 2, if we have to skip 111 numbers which are starting with 1, right? Those will come before the 2. Now the next thing we need to check is how many numbers we need to skip. We need to skip 236 numbers. So can I skip all the numbers which are starting with 1? Yes, because it is only 111 first numbers, right? So if I skip that, then the new k value will be 236 minus 111. So this will be 5, 2, 1. So my current value is 125, which means I need to still skip 125 numbers, and my current value is equals to 2 because I have skipped everything starting with a 1. So this is my current value. Okay, we are pointing to 2. Now again I will repeat the process with 3. So I will pick P1 as 2 and P2 as 3. Now in this case I will find out how many numbers I have to go through which are starting with 2 before we start any number with 3. Okay, so the first digit contribution here is 3 minus 2, which is 1, plus the 2 digit contribution here will be 20 minus 30. I mean, you take the absolute or you do 30 minus 20. So that will be 10, plus the 3 digit contribution will be 300 minus 200, which is 100. And definitely you will not have 4 digit contribution because this is out of bounds. So the total contribution, the total numbers which will start with 2 and come before 3 will be 111. How many numbers we need to skip? We need to go to the 125th number, right? We need to skip 125 numbers, let's say. So definitely I can skip all the numbers starting with 2 because they are less than how many I need to skip, right? So the new k value can be made as 125 minus 111, which will be 410, which will be 14. And I can say that I will skip all the numbers starting with 2 and I will simply reach to all the numbers starting with 3, and I will compare it with all the numbers which are starting with 4. So my current pointer is pointing to 3. So I will write my current is equals to 3 in this case. Okay. And I want to skip 14 numbers now. Let's say that my prefix 1 is 3 and my prefix 2 is 4. I will repeat the same process. What I do is I will find out how many numbers will be starting with 3 which comes before I write any number starting with 4. Let's count that. How do you count that? Again, we will repeat the same process. First, find out the difference between this 4 and 3, which will be equals to 1. Okay, plus go to the 2-digit numbers by multiplying by 10 all the time. So take the difference, add it. It is 10. Go to the 3-digit number. It is 400. So the difference will be 100. And then go to the 4-digit number. But in this case, the 4-digit number will be out of bounds of the n value. So I will not count that. The total values which will start with 3 before you start any number with 4 is 111 again. Now in this case, I needed to skip only 14 numbers, right? So what does this suggest? This suggests that your answer must be starting with 3. Okay, we should not go to 4. So we cannot skip all these bunch of numbers starting with 3. What we need to do is we need to increase the zoom level and start exploring more options within 3 itself. So what I will do is, now I know that my answer will definitely start with 3. Okay, it will definitely start with 3. So what I will do, I will descend from 3 to 30. And when I descend, this 3 has to be included. And since this 3 has to be included, my k will be updated from 14 to 13. Because 3 has now been included, my current value is 30. Again, at this level, I will try to skip as many items as I can. So let's say this is prefix 1. Let's find out prefix 2 as well. So if I find out prefix 2, this will be, let's say, 31. Okay, this is prefix 2. So in this case, what I want to calculate is all the numbers, how many numbers do I want to skip which are starting with 30 before I write any number which is starting with 31. Okay, let's count that. So in this case, take the diff which is 1 plus you go to the 10th multiple which is 310 and the difference will be 10. You add it, you go to the next number, it is 3100 out of bounds, go back. Okay, so the total numbers you need to skip are which are starting with 30 before going to any number which starts with 31 is 11 numbers. Now how many numbers I want to skip? 13 numbers. Okay, so I can safely skip all the numbers starting with 30. Okay, so let's do that. If I do that, then my current, if I skip all the numbers starting with 30, my current will be moving to 31. Okay, so my current will be moving to 31. How many numbers I am skipping? 11 numbers. So my new k value will be 13 minus 11, which is 2. Okay, so let's make this the prefix 1 right now, and let's take something else as prefix 2. Let's say 32 as the prefix 2. Okay, which is the next number at this level. Again, I will repeat the same process and I will find out how many numbers I have to write starting with 31 before I reach to any number which will start with 32. So that will be equal to, take the diff. It will be 1 plus, take the 10th multiple, the diff will be 10 plus, take the 10th multiple again. So this will be 3200 and this is out of bounds, so go back. So the total contribution is again 11. Okay, and you see that can I skip 11 numbers? No, I just had to skip 2 numbers. That means the answer must start with 31. Okay, so once I know that that the answer will start with 31, so let's descend, let's zoom in. Okay, so my current will now be moving to 310 because I know that the number will be starting with 31. What will be my k value? My since 31 has to be included, so I will include 31, therefore k value will change from 2 to 1. Okay, let's now repeat the same process. I will take another parallel number, like the next number at which is of 3 digit will be 311, and I will again repeat the process, how many numbers I have to skip so that I start any number with 311. Like how many numbers starting with 310 I have to skip so that I start any number starting with 311. So take the diff, it will be 1 plus, you go to the next level by taking 10th multiple. This is out of bounds, so go back. So in this case, total I need to skip only one number to start any number with 311. So my current will become 311 and my k value will become 0 in this case because I can subtract. As soon as the k value becomes 0, whatever is the current is my answer. So in this case, if your n value is 536 and you want to find the 237th rank number, then the answer will be 311. And this is the entire approach of skipping all the numbers in this case. So you see that we have not drawn the entire recursion tree diagram, but I have shown you a skipping strategy. So let's analyze the time and space complexity. We are not using recursion in this case. It is an iterative code. So the space complexity will be order of 1. But when it comes to time complexity, you see that the first level consists of the 1-digit number. The second level consists of 2-digit number, and so on. The last level will consist of maybe 10-digit number because of the constraint, right? So I will never have levels more than 10. And this can basically be said that the number of levels will depend on n value. It will be log of n base 10 because it is a base 10 number system and we are increasing in multiple of 10, that is power of 10. That is why it is log n base 10. But when you write in terms of time complexity, we do not mention the base. Okay, but 10 is a very high compression function as compared to your log base 2. Okay, so in this case log n are the number of levels, but even at every level what may happen is you might skip all these items and end up at the last item, which is the 9th item. For every level maybe you are skipping all the items. Maybe from 1 you went to 9, and again from 9 you went to 90, 91, 92, 93 and so on till 99. That can happen, right? So at every level, like even if I take for the first level, the next number is 11, 12 and so on till 19, right? So even if you have gone to 9, there can be 90, 91 and so on till 99. So you can go to 99. The next number can be 990, 991, 992 and so on till 999. So at every level you may have to take approximately 9 to 10 steps, which is log of n again. And the number of levels are also the same. So the time complexity will be a multiplication factor of log n multiplied by log n, and that will be order of log n whole square, right? So this was the entire analysis. Let's now look at the code. Now this is the code which is taken from the LeetCode editorial, and it is one of the cleanest possible code. So it's very good to follow. Now in this case, find kth number is our main function, and we are given an n value which is the bound and k value which is the rank. So I will start with 1, and 1 is the number which will be included. So my k value will include 1, so it will decrease by 1 value. Now this is the loop which I was talking about, which will keep on decreasing the k value unless k becomes 0, and as soon as k becomes 0, this means I have skipped k items, and so the current value will be my answer. Okay, now I will count the number of steps as I had shown you. Like what I was doing was, when I was at 1 using a prefix 1 and I was at 2 at prefix 2, then I was counting how many numbers will start with 1 before I start any number with 2, right? And I kept on finding the difference and multiplying by 10, finding the difference, right? Why I was doing that? Because I have to add the contribution for 1-digit number, 2-digit number, 3-digit number and so on. But we should not exceed n value, right? So for contribution of all the digits, we will be multiplying by 10 to go to the next level every time. Prefix 1 is the left one, which is the current value pointer, and the prefix 2 is the right one, as I had already mentioned, right? So in this case, I will be going top down and I will be adding up all the difference values in the steps, and I will be returning the steps. Now, if the number of steps happens to be less than equals to k, then I can skip everything which starts with prefix 1. Okay, like in this case, if the number of items, like the number of steps was 111, but the k value was 236. So I can skip everything which starts with 1. Okay, that is the logic here. So if I can skip, then definitely I will skip it, and I will do current plus plus. That means the current was 1. Now I will make it 2. This will automatically skip everything which starts with 1. And I will decrement the k value by the number of steps I am skipping, right? So in this case, I had subtracted with 111. Okay. And like this, we will continuously keep on repeating. But at some point, let's say at this point, when the prefix 1 was 3 and prefix 2 was 4, I was not able to skip everything starting with 3 because my answer was starting with 3, right? So in that kind of scenario, what will happen is the contribution, the number of steps in this case was 111. The k value was less than the number of steps to skip every number with 3. So if that happens, that if the steps are greater than k, then I will not jump to the next number, but then I will just descend down, because I know that since the number of steps are more, so then answer must start with 3. So I will descend down and I will include this 3. So what did we do was, we do k minus minus, and descending down means going down a level, but so multiplying by 10. Okay. Now if you look at line number 6, there is a caveat, and this mentions that if we go from, let's say, 200 to 300, then how many numbers were we counting? We were counting exactly 100 numbers. But if you carefully analyze, the numbers will range from 200, 201, 202 and so on till 299, but it will not include 300. It will not include 300, right? So if I hit a range value n, like if I hit n and if I need to include it, like if I start from x and go till n, then the number of items will not be n minus x. It will be n minus x plus 1 if you want to include n. So just to make the last item inclusive, if we happen to hit the bound of n, that is why we have given n plus 1. If you ever wonder like why have we added n plus 1 here, okay? So I think rest part of the code is very simple to understand and I hope you were able to get it. If you have any problem, then please comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of this programming videos. See you guys in the next video. Thank you.